Welcome to the lesson 12 of the Advent of SysML V2. This is a training series consisting of short videos and exercises brought to you by Sensmetry in collaboration with Vince Molnár. My name is Kestutis, and today we'll begin tackling one of the most complex parts of SysML, connections. This whole topic will require 2 lessons. In this first lesson, you will learn about the connections, cross and reference subsetting, and cross multiplicities. Let's begin. Connections are parts that connect other elements. You can avoid them if you want by using referential usages to refer to other elements, but when it comes to bidirectional relationships, they implement an essential pattern, linking 2 things together and let you navigate from either side. Here we are modeling the connection between reindeer and Santa sleigh, which is actually the harness itself. Look at lines 3 through 9. We have 2 part definitions, sleigh and reindeer. Line 4 shows that a sleigh has an abstract reference to reindeer with multiplicity 9. Line 8 shows that each reindeer has a reference to the sleigh it's pulling. Now look at line 12. We declare harness as a connection definition using the connection def keywords. It's just like a part definition, but as a connection, it has ends. The first end is on line 13 and is a part called sleigh, typed by part definition sleigh. The second, on line 14, is called reindeer, also typed by reindeer definition. Let's look at new keywords. First, the end keyword denotes an end feature. Connections can have arbitrary features just like every part, so this keyword tells SysML that we are declaring the ends, not just a regular feature. The trickier part is the crosses keyword. This denotes cross subsetting. Semantically, it's no different from a regular subsetting, but it's used specifically to denote cross navigational features, the features that let you hop over the connection to the other side. In this case, sleigh crosses reindeer.pulling means that when a sleigh and a reindeer are connected with a harness, the sleigh can be accessed through the reindeer's pulling feature. Similarly, reindeer crosses sleigh.reindeer means reindeer pulling the sleigh will be a value of the sleigh's reindeer feature. With cross subsetting, we have specified how to populate the pulling usage in reindeer and the reindeer usage in sleigh. If you don't specify the crossed features, the 2 ends will still be connected, but there will be no easy way to navigate through the connection. Once we have the definition, it's time to use it. Note that connection definitions are optional. Just like parts, connections were fine without a definition if you don't need to reuse it. Now focusing on the model, it includes the context in which the sleigh is being pulled by the reindeer as a part definition. Looking at lines 18 through 31, this assembly contains sleigh on line 19, an abstract reindeer with multiplicity 9 on line 20, and Rudolph on line 21, subsetting the abstract reindeer using the pattern learned in previous lessons. Now we model the connections on 2 levels. First, a general connection between the sleigh and all reindeer, then a specific connection for Rudolph. Line 25 shows the shorthand notation for connection usages. The structure is connection keyword, then the name harnesses, defined by the type harness, then connect keyword, the source end, to keyword, the target end. Notice the numbers in square brackets before the feature names. 1 sleigh to 9 reindeer. These are cross multiplicities. Cross multiplicities are among the less intuitive concepts in SysML, but they are crucial to understand. They do not mean that connection instances, also known as links, are connected to that many elements. A link is always exactly 1 element on each end. What cross multiplicities specify is how many elements on one end must connect to a single element on the other end. In this case, each sleigh must connect to 9 reindeer, and each reindeer must connect to exactly one sleigh. Since we have one sleigh and 9 reindeer, this creates exactly 9 links. This is why you should avoid specifying a multiplicity on the connection usage itself. The cross multiplicities force the number of links, and a contradicting multiplicity would make the model invalid. This diagram illustrates how cross multiplicities can be violated. Here we have 10 reindeer and 2 sleighs with 10 links. The red dot marked 1 is not connected to any sleigh, violating the constraint that every reindeer must connect to exactly one sleigh. Instance 2 is connected to 2 sleighs, which is also a violation. And instance 3, which is a sleigh, is connected to only 1 reindeer instead of 9. That's also a violation. After this theoretical detour, let's look at the longhand notation on lines 26 through 29. This is useful when you need more control over the ends. The declaration connection subsets harnesses resembles the connection definition, with both ends redefined to add reference subsettings. A reference subsetting, like cross subsetting, is semantically just a regular subsetting, but it has a special role. It explicitly denotes which feature is being connected. Notice, in line 27, we used a qualified name here, because sleigh is defined twice in scope. Line 28 shows the end is connecting specifically to Rudolph. The cross multiplicities 1 appear after the end keyword in the longhand notation. So what is the best practice? You could define cross multiplicities in the connection definition, but that's not recommended. It would constrain every sleigh and reindeer instance regardless of context. It's best to leave connection definitions unconstrained and specify multiplicities in the connection usages. To summarize, use shorthand notation with connect to for simple cases. Use longhand notation with references when you need more control. Cross multiplicities specify how many elements connect to a single element on the other end, not how many links exist. In this lesson, you learned a lot about SysML v2 connections, and tomorrow we'll continue on this topic. Your today's challenge is to add connections for the remaining 8 reindeer, add Santa himself, and connect him to the sleigh. Go to the blog post to see full task details. Share your experiences and feel free to ask any questions in our community forum. Links and information on how to get access to Syside Cloud Platform is available in the video description. Subscribe to our YouTube channel and click on the bell icon to get notified about future lessons. Take care and happy modeling!